with the University of Florida Shellfish Extension Program. And today I'm going to be presenting on our urchin project results. Now, this photo might seem familiar to some of you. Bill Walton presented this work. He's formerly with Auburn, and he presented this at the Oyster South Symposium in 2020. Now, biofouling control methods can be a very major expense and effort for our off-bottom oyster growers, and a lot of them showed interest in the potential use of urchins as a novel biofouling control method in hopes of reducing labor costs and increasing profitability for their farm outcomes. In this pilot study, they used wild adult urchins, and they stocked at different densities with subadult oysters. This was done in floating cages at 2 locations in Florida, and these were overwintered and harvested after 5 months. Now, the preliminary results showed that the urchins had no effect on oyster performance, and that there was biofouling reduction on the oysters, and cleaning time decreased with the increasing number of urchins present. So we took this proof of concept and moved forward with it in our study to reevaluate the co-culture of urchins with oysters, this time using hatchery-produced juvenile urchins through the entire production cycle. Now, this was led by Leslie Sturmer at UF and Steve Watts at the University of Alabama, in partnership with Bill Walton, who's now at VIMS. We had 4 main objectives. The first was to document hatchery production of green sea urchins, juveniles, determine the performance of oysters with or without urchins, and we wanted to do this in the field nursery, intermediate grow-out stage, and the final grow-out stage. We also wanted to evaluate different commercial farm sites. So we looked at Alligator Harbor, which is a high salinity site, Oyster Bay and Skipper Bay, which have variable salinities, and then Cedar Key, which is our medium salinity site. Alligator Harbor and Oyster Bay were locations used in that previous pilot study. And our last objective was to assess the biofouling on the oysters and the bags themselves with or without urchins. So looking at that first objective, the goal was to produce hatchery juvenile urchins. Broodstock was sourced from St. Joe Bay, and the idea was to use a closed system hatchery at the University of Alabama. Unfortunately, a lot of problems occurred with water quality, bacteria, food production, and amphipods, and those juveniles could not be produced. So for the remainder of the study, we sourced wild urchins from St. Joe Bay. So moving into our field nursery, again, we used juvenile wild sourced urchins, and we stocked these with R6 triploid oysters. These were stocked in 4-millimeter bags, and the floats were placed on the slide. We also looked at 2 different treatments. One having oysters stocked at 1,200 per bag. This one had 12 juvenile urchins placed in it. Treatment B is considered our control, so it was just oysters, and we asked the grower to flip the bags as they typically would for their management practice. And then treatment C was just urchins. So looking at some of our results, our first farm site was in Cedar Key. This is located in open waters and has variable weather conditions. Here you can see our wind graphs, and we did experience gusts of over 30 miles per hour. So just 20 days after stocking, we had no live urchins in the bags. A similar fate was observed at Oyster Bay. Salinities were around 20 parts per thousand for the duration of the nursery study. And just after 22 days, there were no live urchins again in the bags. And here at the bottom of the photo, you can see that there's urchins with the spines already drooping or no spines present at all. Looking at our other sites, Cedar Key, salinity ranged from 21 to 31 parts per thousand. And then Alligator Harbor had high salinities at 30 parts per thousand that were stable. Alligator Harbor was the only location where urchins performed well during this nursery stage. After 19 days, we had 100% survival of urchins that were stocked with the oysters and 68% survival of urchins stocked without oysters. This is a harbor, so it is well protected, and again, it had those higher salinities that are favorable for urchin production. After 2.5 months, though, only 36% of the urchins survived in bags stocked with oysters. And then in terms of our oyster performance, the urchins had no effect on growth or survival. We then wanted to look at this intermediate field grow out stage. Again, we stocked 3 locations, but conditions at Cedar Key and Oyster Bay were unfavorable. So we're only going to present on Alligator Harbor. We again used wild juvenile urchins and stocked them with our triploid oysters at 400 oysters per bag. We looked at different urchin densities, 0, 15, 10, and 20. And then we also looked at varying the float placement. So in the first study, we had floats just placed on the side. This time we looked at side placement and top placement. We had 4 treatments in total. Treatment B is our control, so there are no urchins present. And we asked the growers to flip those bags as they usually would for their biofouling management practice. Treatment A is a little bit different. The oysters used for that came from our Cedar Key nursery field trial, because they were heavily fouled already with barnacles. Compared to the oysters that you see in A, B, and D, these oysters came from Alligator Harbor from that same nursery field trial, except they were relatively clean. They had really no biofouling or barnacle growth on them. So now we're going to get into some results. The first of which is looking at our urchins, and we see that treatment E had larger, heavier urchins in comparison to treatments A and D, and those were stocked at 10 urchins and 20 urchins. In terms of survival, we again see treatment E has higher survival at 98%, followed by treatment A at 87% and treatment D at 53%. Now, treatments E and A both had floats placed on the top, allowing those bags to sit lower in the water column. Now, looking at oyster performance, we see that the urchins had no effect on growth or survival between the treatments. We also wanted to quantify the amount of fouling on the oysters and the bags. So the way we did this assessment for the oysters is we hand counted the number of barnacles that were present at stock and then again at harvest. And what we saw was in treatment E, we had a 64% reduction of barnacles. I want you to closely look at treatment B. This was our control as well. You can see that there's a matrix of amphipods. There's a lot of sediment and detritus. This was very difficult for us to quantify. Every time we picked those oysters up, that kind of just dislodged or slothed off. And this could be a little making it difficult for the oysters to feed. We also quantified the amount of fouling on the bags at harvest, and the way we did that was we weighed the bags with the floats removed and then subtracted the initial bag weight just to get that fouling mass. Weights were higher in bags where the floats were placed on top compared to the bags where the floats were on the side, and that's because those floats on top were able to trap all that macroalgae or any other type of biofouling predators on top there, making them heavier. We then moved on to our final grow out stage in Alligator Harbor. Even though the oysters had already reached market size, we stocked these at 150 oysters per bag. Again, we looked at varying the float placement between top and the sides. This time around, though, we looked at juvenile urchins versus adult urchins. So looking at growth and survival for the urchins, this was very similar to what we saw in that intermediate grow out stage. The juvenile urchins did have a faster growth rate in comparison to our adult urchins. But again, in treatment E, we had a 96% survival of urchins. And then looking at our oysters, urchins really had no effect on size or survival. For biofouling, again, it was a similar story to what we observed in our intermediate stage. For treatment E, we saw a decrease of 59% in our barnacles. I also wanted to note for our fouling weights in the bags, the lowest observed weight was in treatment F, which had 20 adult urchins and the bags placed on the, or floats placed on the sides. For this final grow out stage, we did do a study at Skipper Bay, this time using floating cages. I'm not going to present those results today, but they are very similar to what was observed at Alligator Harbor. So in summary, just to have a few key points here, the reliance of wild urchins just is not realistic. We really need a reliable source of hatchery juvenile urchins if we want to continue this commercial development. We also need to look at our sites. We need sites that are high in salinity and are protected from those prevailing winds like we saw at Alligator Harbor. I do want to note though, for the duration of the study, the oysters were relatively clean and free of fouling at Alligator Harbor. And then the last thing is looking at gear types. We might be restricted to those floating cages because they are able to sit lower in the water than the urchins. And then since this study was looking at co-culture, conditions really need to be favorable for both the urchin and the oyster. And our results show that that might not be the case here on the Gulf Coast of Florida, especially in sites like Cedar Key and Oyster Bay. We also didn't look at the other practices that you typically do with oysters, like tumbling. How would that affect the urchin survival? And lastly, these findings really show the limitation and the potential use of urchins with co-culture oysters. And with that, we really want to thank all our participating growers. We have some here today. Thank you so much for your time and your effort. And then we'd like to thank our funding source, Gulf State Marine Fisheries. Thank you guys.